think we're ready to start. There's a couple more seats in the middle, but I'm not sure if they're reachable. Good afternoon, everyone. There's one or two talks left, so I hope you still have the energy. And you're actually in for a surprise. So the title of this session is Build Scalable APIs Using Serverless. But I've added a little extra for you. Is anyone here excited about learning about GraphQL? Yeah? There's a couple of hands. That's awesome. Cool. So today we're going to look into how we can build APIs using serverless and GraphQL. And Agnes here is going to walk through this journey with us and try to understand what these two technologies, which seem kind of unrelated, actually do have in common. So the first thing that GraphQL and serverless have in common is that they're both riding the hype train. So right now, as I'm speaking, I bet there's at least one library that has been created for both GraphQL and serverless, contributions from the community. Everything's happening so fast. So yeah, they're definitely on the hype train. If you're looking to learn some new stuff, serverless and GraphQL are the things that you should definitely look into. The other thing that they have in common is that both of them seem to be very liked by JavaScript developers. And one of the reasons why that is because serverless basically allows you, as a JavaScript developer, it allows you to kind of break that bridge, break that barrier, and go into the backend side of things and write your own APIs. GraphQL, on the other hand, if you're a front-end developer, it helps you retrieve the data that you need. It helps you shape the data that you're going to retrieve from your backend, and it helps you use your APIs in a more simple and more, in a simpler way. Another thing that they have in common is a timeline. Both serverless and GraphQL have been released into the wild towards the end of 2014 and the beginning of 2015. So it kind of makes sense that both of them are on the hype train at the same time. GraphQL was open sourced at Facebook in 2015, and serverless came to existence in AWS around the end of 2014. But there's one more thing, a magical thing that brings them together. And that's what we're going to look into today, and that's the journey that we're going to go through. So let's start with GraphQL. When the team at Facebook started rewriting their mobile applications towards the end of 2012, they basically wanted to build a data fetching API powerful enough to describe all of Facebook. And I'm going to let that sink in. All of Facebook. Fact from Asim Hussein seems that whenever we're making a request to Facebook, they're going to make probably 1,000 other requests in order to retrieve our data. So let's have a look at kind of how does our timeline or how does our homepage look like? If we look at this screenshot, on the left-hand side, which is my left-hand side, but your right-hand side, we have links to the Messenger app. We have links to some of the events that have been suggested to us. In the center of the page, we have posts that have been created by our friends. And then on the right-hand side, we have things like stories that have been created by our friends, some friend suggestions, and some events. So that's a lot of data that needs to be retrieved, and it's a lot of data that needs to be rendered on this page. And if we were to think from a REST perspective, what kind of requests we'd have to create? Maybe we'd have to retrieve the user information based on the ID that we retrieved when we logged in, as well as the event suggestions, friend suggestions, and friends' birthdays. And in a RESTful manner, when we are retrieving events information, we would be retrieving all this information. Things like what's the name of the event that we have displayed, we have retrieved? What's the location of the event? What's the organizer? What are the attendees? So a lot of information. But what we really need when we look at this page, we only need the number of events. So here we're displaying 4 events that have been suggested to us, and that's it. So what does that mean? We're retrieving an array of information, but all we need is a number. And that takes us to, that gives us 2 options. The first one is where we're overfetching data, so we're retrieving more data than we actually need to display on that page. Or the other option that we have is to add a new endpoint. And adding a new endpoint means that we would basically have to sync up between the front-end team and the back-end team and make sure that we're either adding a new endpoint or modifying an existing one to add that tiny bit of information. We only need the number of events that have been suggested. None of these options are ideal. We don't want to be overfetching data because that means that we are basically retrieving more data, so we are wasting data. I am currently on roaming, and I do have a limit to the amount of data that I can use. Whenever an application or a website that I'm using is overfetching data, it's basically kind of stealing money from me, right? Because I will have to pay for that data that I'm not using. Adding a new endpoint means that both our teams, the backend and the frontend, need to work more, and that's not ideal either. So let's go and look at a different example. What about friend suggestions? So here I'm being suggested to friend Galnaz, and you can see that I'm being displayed her profile picture, her name, the number of mutual friends, and the option to add her as a friend. If I were to think of this from a REST perspective, basically I would have to retrieve the list of friend suggestions, which is an array of people information, and I'd have information like her name, her profile picture, and then a list of an array of mutual friends. And then I would have to make another request so that I can retrieve that list of mutual friends with all the attached information. So this is the typical N+1 problem, where basically you are retrieving one resource, and then you have to make other N requests in order to retrieve all the information that you need to display, in order to display information about a unit. You'll find this kind of problem in databases as well. And this is known as underfetching. So we're retrieving less information than we actually need to display. And that's one option, making more requests. Or, again, we can add a new endpoint or modify an existing one, but that means we have to sync up the teams. This is not ideal either because we have to make multiple round trips to the server, and that means that our performance is going to kind of suffer. So this is actually why it's very important that we don't overfetch or we don't underfetch. If you, this is a table from a book called High Performance Browser Networking. I highly recommend you check it out if you're interested in web performance. It's definitely something you should look into. Basically, here you can see that depending on how much time users need to wait for your data to load, you're going to lose them on the way. And when it's more than 1 second to retrieve that data, they're going to context switch. If it's more than 10 seconds, they're just going to move away. And whenever we're making more round trips, we are basically making more requests. We are sending headers which are not being compressed. And that's for HTTP 1. With HTTP 2, the story changes, but a lot of our websites and a lot of the applications that we're using are still using HTTP 1. So we have to kind of cater for those users and those use cases as well. Yeah, so we need to have performance in mind. And another quote from this book is that the fastest network request is a request not made. I know this is obvious, but we have to keep that in mind. And that's exactly what GraphQL helps us with. When we're making a GraphQL request, we're basically describing all the data that we need, and we're going to execute a single request. So here you can see how we can read some data that will theoretically display all the information on my Facebook page. So I start by saying that I'm executing a query right now. And the query that I want to execute is called user. And I want to filter by ID one. And then I want to filter the data that I'm receiving. So I only want to receive the name of the user, the events, and within those events, I only want to retrieve the number of events. And then the friend suggestions with their name and mutual friends. So right here, I am filtering the data that I want to retrieve. And this is how the response looks like. It's a JSON object that basically mirrors the query that I've made. And that's perfect. That's ideal, because that's exactly what we want. We don't want to have to parse all the data, filter out all the data that we're retrieving. We want to be able to retrieve only the data that we need. And whenever we're starting using GraphQL, we're basically starting with a schema-driven development approach, where the front-end team or the back-end team, or basically the client team and the back-end team will sit together. They're going to design a schema together, a contract, defining the operations that need to be available. And that schema is strongly typed. And what that means is that we'll have tons of advantages, like be able to do introspection and also auto-completion and a lot of that information. So to look into that, basically we can define a type people where we have fields like ID, which is of type ID, and that's a scalar type in GraphQL, and that's the equivalent of primitive types. So it's a type that's already defined by GraphQL. Name is of type string, and then avatar is of type URL. And URL is a custom scalar type. So we are able to define scalar types within GraphQL that are custom to us. Think of date. Date is a special type where we would want to validate the format of the date. And we can do that in our applications by just defining a custom scalar. We also have nested types. So here, a team can contain a list of people. And you define a list by using square brackets. And then here are the operations that are available for us in GraphQL. We can define queries, and queries are basically the get operations from a REST type of approach. And this is reading data from our backend. And then here we are defining the contract, so the name of the operation and the type of data that's being returned. In this case, we are calling the operation teams, and we are returning a list of team. The type mutation allows us to update data on the backend. And again, we define the name of the operation and the type that's being returned by that. And that was a contract, almost like an interface. And this is how we would actually go ahead and implement those operations. So we have to define a way to retrieve that data. And in this case, I'm calling two existing endpoints, which are REST endpoints. And that's a very common use case for GraphQL, where you basically take your existing APIs and you add a GraphQL endpoint on top of that. Because most of us don't get to work on green projects, on greenfield projects, where we create new projects from the start. This is a tool that if you start working with GraphQL, you're going to love. It's called Graphical, and it allows us to inspect our API. And we get features like real-time documentation, where you can see what kind of operations are available for you and what are the types that are being defined on our API. But we also get things like auto-completion. So you can see here, as I'm typing, I'm going to get all the data that I have available on my API. It gives me error validation or query validation as well. So I'm being prompted here that this operation doesn't exist. Is there this other operation that I wanted to call? So why do you want to use GraphQL? Well, if you care about the performance of your application, you should definitely use GraphQL. We make only one request and retrieve all the data that we need. It gives us flexibility. As front-end developers, we only query the data that we need, and that's perfect. And finally, we have a lot of great tooling available. Things like graphical, that's just one example. We also have tools like things that will help you with schema generation and caching and libraries on the front end. So there's a lot of tooling available for us. And that was GraphQL. What about serverless? The line of code that's fastest to write, that never breaks, that doesn't need maintenance, is the line you never had to write. That's something that Steve Jobs mentioned in one of his keynotes many years ago. But this is basically true for serverless because we don't have to write configuration code. We don't have to deal with that. And serverless allows us to only write the code that we need and reuse existing services. And to get a kind of overview of what serverless is, Jeremy here is going to give you a full-length session on serverless. But just to give you an idea, basically serverless, when we're writing serverless applications, we're writing applications that either depend on third-party services, or we write custom code in a serverless platform that's basically just code that's specific to our application. And there's a couple of things that are very important here. The first one is that our serverless code is code that reacts to events. So we can only execute code in reaction to certain events like HTTP triggers, or HTTP requests, or messages being posted on a queue, or files being uploaded in a storage account. And we can execute code in reaction to that. Another key thing with serverless, and something that we absolutely love about serverless, is that our code will auto-scale, and we don't have to do anything about that. So the cloud provider will make sure to spin up as many servers. There are servers, I promise. We'll spin up as many servers as we need in order to serve all those requests. And finally, we only pay, it just goes away. You only pay for what you need. So you only pay for the CPU time and memory that's being used as your code is running, and that's it. And this is a hello world of a serverless function. And you can see here that I get two parameters. The first one is the context object, and the second one is the request. This is an example of an HTTP triggered function. And we're returning a response that contains hello, and then the request, we returned a string that came with the request. And then I'm going to quickly demo how you can get started with serverless. How many of you have actually written serverless code? OK, there's maybe 15 hands in the audience. How many of you have used Azure Functions before? Probably 3/3 of those hands. I'm happy to see that. So for those of you that haven't written serverless code, this will probably look natural. Let me see if I can get this right. Oh, right, I am mirroring my screen now. So right now, I'm using VS Code. I hope all of you here are fans of VS Code. And I hope that you can see this OK. I have an empty folder here, and there's this Azure extension. That's the Azure icon that will help me create serverless functions. And in order to do that, I'm going to use the Azure Functions extension, which you can download from the extensions marketplace, from the VS Code marketplace. And the first thing that I'm going to do is create a new project. And you can choose different types of projects. So you can choose to create a C# project, or a JavaScript one, or even a Java project. But I'm going to go with JavaScript. And this project is basically just like an environment. a group. This is a place where you're going to group your functions. So then I have to create a function that will react to those events that I mentioned earlier. You can react to HTTP requests or blob storage or even Cosmos DB. We can listen to changes in a database and execute code in reaction to that. I chose HTTP because it's the easiest one to trigger and just to see, but I recommend you go check it out and kind of try all the others as well. So now if I go to my code, you'll see that I've been created a couple of folders here. The first one, VS Code, is the configuration for me to debug the serverless code I've just written. The second one is the actual code for my function. And right now what we have here is the function.json file, which is the configuration code for the function, which is telling me things like what type of trigger this is, what is this a input data source, or is this an output one? For output, we're returning a response, and then for input, we're listening to some get or post requests, and then we are using the rec object to read data from. And finally, we also have access to things like local.settings.json file. And this is what we would use to define environment variables. So things like if we're connecting to a database, this is where you would actually save your secret environments. Or you can put them in your code and then check them into GitHub, and then GitHub will tell you that this is not OK. They've announced that they're actually implementing security where they're going to send you immediately alerts about keys posted on GitHub. Never do that. So in order to run this function, I go to this debug icon, which probably is not very visible right here, and then hit play. And this is going to start the Azure Functions CLI, the Azure Functions runtime, which I have installed in my own environment, on my local. Azure Functions is open source, which means that we will get in our local the exact version of Azure Functions that's running in the cloud. And that also allows us to debug things locally, easily. So now you can see that I've been given here a URL where I can run my function. And then it will tell me that I have to trigger, I have to pass in a name. And just to show you how easy it is to debug as well, I'm going to quickly add a breakpoint here. And then I'm going to refresh. And bam, it will stop. And I can go ahead and inspect. Imagine in a case where you're actually debugging this application because you have a bug, you can inspect elements here, and you can inspect the data that you have received as part of the request. Azure Functions is actually built on top of App Service. And with App Service, we can debug applications that are running in the cloud as well. So imagine that kind of capability coming to serverless. I think that's pretty powerful. That's pretty cool. Another thing that we can do with Azure Functions in VS Code, we can deploy them to the cloud because we've written all this amazing code. We have debugged it. Now we probably want to make it available for other people as well. We can do that easily by just clicking this publish arrow. But a colleague of ours will tell you that friends don't let other friends right-click deploy, right? If Burke here would have written a cool function for all of us, and then I would just go and override that with my Hello World application, that wouldn't be very cool, right? So then we have this other option where you can actually go into the Azure portal and connect your function to a GitHub repository or any other type of version control system. So we have this deployment center option where you can choose your source control, and it can be things like GitHub or Bitbucket, Dropbox, if anyone here stores their code in Dropbox. And this is just the beginning. because you can actually use Azure DevOps to implement a full CI/CD type of pipeline where you actually run your tests and then you deploy your functions to the cloud. So I hope that this gave you an idea of how you can work with functions. These are just recorded slides in case things don't work out. The power of serverless is not only the code that you write in your functions, but it's also the data sources and the third-party APIs that you can connect to. You've already seen that we can connect to Cosmos DB, to table storage. We can read data from there. The way you would do that is either using your favorite IDE, or you can go ahead in the browser and select here. You can integrate with some of these sources. And I'm going to show you quickly how excellent it is. So in our function.json file, we can define the data source that we have by adding this new binding. You can see here that I'm connecting to Cosmos DB, what kind of database collection, what's my connection string. The connection string is going to be read from the local.settings, from the app settings that we've seen earlier. And then to use that data source, to read from it, we only need to access context.bindings.input document. And that's it. This is going to be a pipe to our database. I find this very powerful. It's a single line of code. And this is exactly what serverless allows you to do. It allows you to connect to different data sources and APIs. So why would you use serverless? Well, because you can build reusable APIs very fast. You can use your favorite tools to do that, things like VS Code or Visual Studio. And it gives you easy integration with different data sources. So most of the times, the cloud provider will do all the heavy lifting for you, and you will have to only focus on writing the code that you need. Plus, there's no servers to manage. So serverless and GraphQL, they're definitely a perfect match. Both ways. When we started writing serverless applications, we had this like a monolith kind of environment, or maybe microservices. And we started migrating away to functions very shyly, kind of implement some of the backend stuff, cron jobs, using serverless. As we became more excited about serverless, or as we become more excited about serverless, we start moving a lot of the serverless code, a lot of our code to serverless. And very soon, we end up with something like this, which to probably a lot of you will look like madness. Like you have code everywhere, you have endpoints everywhere, and code running in reaction to events everywhere. How do you actually control that? Well, this is where GraphQL can help us. It basically functions like a thin layer API for our API. And we have a single endpoint where we can inspect all the available endpoints that we have. And this is how a function that exposes a GraphQL endpoint would look like. So we are using the GraphQL JavaScript library. And basically, we're passing in the request that we've received, the types that we've defined, and the schema that we've defined for our GraphQL endpoint, the variables. And then we return that response back. And that's pretty much everything. And in our example, we have the browser, the GraphQL endpoint, that's connecting. It's reading data from two existing endpoints. And then those are reading data from a database. But in fact, it doesn't have to be like that. We can also read data from both an existing API, but also directly from the database if we wanted to. More than that, we can actually use caches for that. And that allows us to become faster. And in fact, GraphQL is great when we actually have multiple clients reading from the same data source or from the same endpoint. So why would we use serverless and GraphQL? Serverless allows us to do easy integration with our data sources, whereas GraphQL it allows us to do an easy abstraction of our data sources. With serverless, we get auto scalability, And with GraphQL, we have a single endpoint that will auto-scale. With serverless, we write less code. And with GraphQL, we make a smaller number of requests. And finally, what these two have in common is developer productivity. Because we end up writing faster code, a lower number of lines of code, and our code is becoming more performant. So we achieve more by doing less. And that's what everyone in this room should aim to do. So I highly encourage you to go build something using serverless and GraphQL. And if you have any questions, do reach out. I'm very happy to help you get started on this journey. These are some of the resources that I have available for you. I didn't expect this to be a animation kind of thing. But this is a workshop that I put together with serverless and Azure Functions. It's available on GitHub. Try it out and let me know how it goes. Thank you so much. If you have any questions now, you can reach out. The previous one, right?